When installing electrical components for a septic system, safety and code compliance are paramount. Determining the appropriate wire size for your two 115 volts outlets, each requiring a 20 amps breaker, over a distance of 100 feet, involves calculating voltage drop to ensure the motors receive adequate power. The calculation provided suggests using a wire with a resistance of no more than 0.53 ohms. Using the formula resistance equals length multiplied by resistance per foot, the resistance of various wire sizes can be determined. Firstly, 10 American wire gauge wire has a resistance of 0.99 ohms per foot, resulting in a total resistance of 0.99 ohms over 100 feet. Secondly, 12 American wire gauge wire has a resistance of 0.158 ohms per foot, resulting in a total resistance of 1.58 ohms over 100 feet. Thirdly, 14 American wire gauge wire has a resistance of 0.253 ohms per foot, resulting in a total resistance of 2.53 ohms over 100 feet. Based on these calculations, 10 American wire gauge wire is needed for this application to keep the resistance under 0.53 ohms. Regarding circuit configuration, it's acceptable to run a 3-conductor 240 volts wire to a junction box and split the power to two 115 volt circuits. This method, known as splitting the phase, can simplify wiring and reduce the number of conductors running from the main panel. For wiring the system, you could follow these steps. 1. Run a 10 American wire gauge 3-conductor 240 volts wire from the power source to a junction box. 2. Connect the black and red conductors to the 240 volts breaker in the main panel. 3. Connect the white conductor to the neutral bus. 4. In the junction box, connect the black conductor to the first 115 volts breaker. 5. Connect the red conductor to the second 115 volts breaker. 6. Connect the white conductor to the neutral bus in the junction box. 7. Run separate 10 American wire gauge 2-conductor wires from the junction box to each outlet. Remember to use proper connectors for all wire connections to ensure secure and reliable electrical connections. The junction box should be weatherproof to protect the connections from environmental elements. Furthermore, ensure the junction box is accessible for future maintenance and inspections. It is essential to install ground fault circuit interrupters, also known as GFCIs, on each circuit for safety to prevent electrical shock. Ground fault circuit interrupters detect ground faults and quickly interrupt the circuit, protecting individuals from potential harm. Finally, it is strongly recommended to have the system inspected and approved by a qualified electrician before use. An electrician can verify that the wiring meets local electrical codes, is installed correctly, and is safe for operation. Here is some additional information about wire sizing. Wire size is typically measured using the American wire gauge, commonly abbreviated as AWG. The AWG system assigns numbers to wire sizes, with smaller numbers indicating larger wire diameters. Larger wires have lower electrical resistance, allowing them to carry more current without overheating. Selecting the correct wire size is crucial to prevent voltage drop, overheating, and potential fire hazards. Voltage drop occurs when the voltage at the end of a long wire run is significantly lower than the voltage at the source. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. Overheating can occur when a wire is carrying more current than it is designed to handle. Overheated wires can melt insulation, cause short circuits, and potentially start fires. Electrical codes, such as the National Electrical Code, or NEC, provide guidelines for selecting appropriate wire sizes based on factors such as the amperage of the circuit, the length of the wire run, and the type of insulation. Consulting the National Electrical Code tables is essential for ensuring compliance with safety standards. When determining wire size, several factors must be considered, including the amperage of the circuit, the length of the wire run, the voltage of the circuit, and the type of insulation. The amperage of the circuit refers to the amount of electrical current that the wire will be carrying. The length of the wire run is the distance from the power source to the load. The voltage of the circuit is the electrical potential difference between the conductors. The type of insulation affects the wire's ability to dissipate heat. The National Electrical Code provides tables that specify the allowable ampacities of different wire sizes based on these factors. These tables take into account the wire's insulation type, ambient temperature, and other relevant conditions. To use these tables, determine the appropriate amperage for the circuit and the length of the wire run. Then consult the table to find the wire size that can safely carry the required amperage over the specified distance. Remember to consider any applicable directing factors, such as those for high ambient temperatures or multiple conductors in a conduit. Directing factors reduce the allowable ampacity of a wire to account for conditions that can increase its temperature. For example, if a wire is installed in a hot environment, its ampacity must be directed to prevent overheating. Here's some more information about circuit configuration and splitting the phase. Splitting the phase is a common technique used to create two 115-volt circuits from a single 240-volt supply. In a typical 240-volt circuit, there are two hot wires, a neutral wire, and a ground wire. Each hot wire carries 120 volts relative to the neutral wire. By connecting each hot wire to a separate 115-volt circuit, two independent circuits can be powered from the same 240-volt supply. When splitting the phase, it is essential to ensure that the load is balanced between the two circuits. This means that each circuit should carry approximately the same amount of current. An unbalanced load can cause the neutral wire to overheat, which can be a fire hazard. To balance the load, distribute the appliances and equipment connected to the circuit so that each circuit draws approximately the same amount of power. Using a junction box is a convenient way to split the phase and distribute the power to the two 115-volt circuits. The junction box provides a central location for making the necessary connections and protecting them from the environment. When installing the junction box, choose a location that is accessible for future maintenance and inspections. The junction box should also be weatherproof to protect the connections from moisture and other environmental elements. Within the junction box, use appropriate connectors to make the wire connections. Wire connectors, such as wire nuts or terminal blocks, provide a secure and reliable way to join wires together. Ensure that the connectors are properly sized for the wires being used and that they are tightened securely. In addition to wire connectors, it is also essential to use strain relief devices to prevent the wires from being pulled or strained. Strain relief devices, such as cable clamps or cord grips, secure the wires to the junction box and prevent them from being damaged. Ground fault circuit interrupters are an essential safety device for any electrical circuit, but they are especially important for circuits that supply power to outdoor equipment or appliances. Ground fault circuit interrupters detect ground faults, which occur when current leaks from a circuit to ground. Ground faults can be caused by damaged insulation, faulty wiring, or contact with water. When a ground fault is detected, the GFCI quickly interrupts the circuit, preventing electrical shock. Ground fault circuit interrupters are designed to trip within milliseconds of detecting a ground fault, providing a high level of protection against electrical shock. They are typically installed in outlets or circuit breakers and are easily identifiable by their test and reset buttons. When installing ground fault circuit interrupters, follow the manufacturer's instructions carefully. Ground fault circuit interrupters should be tested monthly to ensure that they are functioning properly. To test a GFCI, press the test button. The GFCI should trip, interrupting the circuit. To reset the GFCI, press the reset button. Consulting with a qualified electrician is crucial to ensure that the electrical work is performed safely and correctly. An electrician can assess the specific requirements of the installation and recommend the appropriate wiring methods, components, and safety devices. An electrician can also inspect the completed work to ensure that it complies with local electrical codes and is safe for operation. Hiring a qualified electrician can help to prevent electrical hazards such as fires and electrical shocks, and can ensure that the electrical system operates reliably and efficiently. When selecting an electrician, choose one who is licensed, insured, and experienced in the type of electrical work that needs to be performed. Check references and read reviews to ensure that the electrician has a good reputation and a history of providing quality work. In addition to the specific information provided, here are some general safety tips to keep in mind when working with electricity. Always turn off the power at the circuit breaker before working on any electrical circuit. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and rubber gloves. Never work on electrical circuits in wet or damp conditions. If you are not comfortable working with electricity, hire a qualified electrician. By following these safety tips, you can reduce the risk of electrical hazards and ensure that the electrical work is performed safely and correctly. Remember, electricity can be dangerous, so it is essential to take precautions and follow all safety guidelines. The information provided is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or other expert before performing any electrical work. Finally, the electrical installation should comply with all applicable codes and regulations. These codes and regulations are designed to ensure that electrical systems are safe and reliable. Failure to comply with these codes and regulations can result in fines, penalties, and potentially dangerous conditions.